Hello students, now today we will discuss energy versus power signal. So previous class also I told you energy versus power signal. So what do you mean by energy and what do you mean by power? Already I told you. Energy E of a discrete time signal x of n can be defined as that is your what E equal to sigma n equal to minus infinite to infinite x of n square. This is your energy signal. So already I told you in your previous lecture. So what is energy signal? So mathematical expression of the energy signal can be defined as E equal to mod of x of n square, and power of the discrete time signal x of n can be defined as that is your limit n tends to infinite, that is your 1 by 2n plus 1, that is your sigma n equal to minus n to n, that is your x of n square. So this is nothing but your energy and this is nothing but a power. So average power P of a discrete time signal x of n can be defined as that is your limit n tends to infinite 1 by 2n plus 1 n equal to minus n to n x of n square. Here the value of n there is nothing but minus n to n. N is nothing but your fundamental period. So already I told you in the previous class. Also we have discussed some of the few examples. So how to calculate energy signal and how to calculate the power signal if the discrete time signal x of n is given. So the discrete time signal x of n is given, you have to find out the energy, whether the signal is energy or whether the signal is power signal. So if the value of this energy, the energy E of a discrete time signal x of n, if the value of E equal to finite, if the energy is finite, if the energy is finite means you will get some final value. If energy is finite and the power becomes 0, we can say that it is nothing but what? That is your energy signal. So energy signal. Similarly, power. If power is finite, you can say that it is your power signal. Power signal. If energy is finite, you can say that energy signal. If power is finite, you can say that power signal. With the help of this formula, we have to derive or we have to evaluate or we have to calculate the value of E of discrete time signal x of n. If the discrete time signal x of n is given and we have to find out the energy of that discrete time signal x of n, if energy is finite, we can say that it is an energy signal, and energy may finite or may not finite. If energy is finite, we can say that energy signal. If energy is infinite and power, then we will calculate whether the power is finite or infinite. If energy is infinite and we have to calculate the power is infinite, the signal is called the neither energy nor signal. If either of the two, it means energy and power both are infinite, we can say that it is a neither energy nor power signal. So in overall, what we have concluded, if energy is finite, you can say that it is an energy signal. If it is power is finite, you can say that power signal. Suppose I will give you an example. So an example. So we have to find out the following, the given discrete time signal, whether the energy signal or power signal. Suppose x of n equal to say 4 whole into minus 1 to the power n, and condition is that is your n greater than equal to 0, that is your n greater than equal to 0, and 0 elsewhere. So we have to find out whether the discrete signal having energy or power signal. So determine, so question is determine the following discrete signal, the following discrete time signal determine the following discrete time signal is energy or power. So we have to determine the following discrete signal, either energy signal or power signal. So solution. So as you know that in a discrete time signal x of n, the E of discrete time signal x of n can be defined as what? The energy E of discrete time signal x of n can be defined as, that is your sigma n equal to minus infinite to infinite x of n square. The energy E of discrete time signal x of n can be defined as E equal to n equal to minus infinite to infinite x of n square. Here x of n is given what? Here x of n is what? X of n equal to 4 minus to the power n, and here condition is n greater than equal to 0. Means what? From 0 to infinite the sequence exists. So that is the limit will lies from what? The sequence will exist from n equal to 0 to infinite. Here n greater than equal to 0 means what? N equal to 0 to infinite. Our limit is your what? N equal to minus infinite to infinite. But here this sequence exists from n greater than equal to 0 to infinite. So that's why the limit will change, that is your n equal to 0 to infinite x of n square. X of n value is how much? 4 whole into minus 1 to the power n square. Okay, in place of x of n you can put this one, and in limit the sequence exists n greater than equal to 0. That's why the limit changes, that is your n equal to 0 to infinite. Then what you will do? That is your what? This is nothing but, so 4 square, that is your 16, and 16 taking the left side of the summation, that is your n equal to 0 to infinite, that is your n equal to n equal to 0 to infinite minus 1 to the power 2n, means what? It is nothing but 1, and this value is nothing but 1. But this is nothing but 1. So value is what? 0 to infinite. If you will add from 0 to infinite times of 1, the result will be what? That is nothing but infinite. This is your 0 to infinite. In n equal to 0, that is 1. Summation means addition. Plus again n equal to 1, that is 1. 1 plus 1 plus 1 up to infinite. The value will get what? That is your infinite. That means this is nothing but 16 into infinite, and the value is your infinite. Okay. So we have got that your energy is your infinite. If the energy is infinite, then we have to check whether the power is finite or infinite. To find the average power, the power P of discrete time signal x of n can be defined as, that is your P equal to, that is your limit n tends to infinite, that is your 1 by 2n plus 1 sigma, that is your n equal to minus n to n x of n square. This is your formula to find the average power of a discrete signal x of n. So here, that is your limit, same procedure as you followed in your to find out the to calculate the energy of discrete time signal. Same procedure you will follow to calculate the average power of P of a discrete time signal. So that is your here limit n tends to infinite, that is your 1 by 2n plus 1. Again the limit will change. The sequence exists, that is your n greater than equal to 0, means what? N equal to 0 to infinite. So that's why in the limit will change, that is your n equal to, that is your 0 to n x of n. In place of x of n you will put 4 minus 1 to the power n square. Okay, only the limit will change here because the sequence exists for n greater than equal to 0. For n greater than equal to 0 means 0 to infinite the sequence exists. To find the average power, that your n varies from minus n to n, the limits will the limit can be slightly modified here, what? N equal to 0 to n, 4 minus to the power n minus 1 to the power n square, and the value will be what? That is your limit n tends to infinite, that is your 1 by 2n plus 1, that is your n equal to 0 to n 4 square, that is your 16, and minus 1 to the power 2n, it is nothing but 1. 1. So 16 it is taking to the left side of the limit, that is your limit n tends to infinite, that is your 1 by 2n plus 1. Tell me, this is your n equal to 0 to n, the sequence, that is your 1. Here what? N equal to 0, that is 1, n equal to 1, that is 1, n equal to 2 equal to 1, up to n. So n times, if you add 1, the value will be how much? That is your n plus 1. Value will be your n plus 1. So that is your 16 into limit n tends to infinite. So here what you will do? This is your n plus 1 by 2n plus 1. N plus 1 by 2n plus 1. So how to evaluate this value of the limit? So that is your 16 into limit n tends to infinite. That is your, you will divide it both numerator and denominator n. That's why 1 plus 1 by n here. Here also divided n. That is your 2 plus 1 by n. Why I am trying to divide both numerator and denominator? As you know that 1 by infinite equal to 0. If n tends to infinite, so try to keep this form 1 by infinite means 0. So that's why if you put n equal to infinite, 1 by infinite 0, here also 1 by infinite 0, the value will be what? 1 by 2. So that's why this is nothing but what? So n equal, if n tends to infinite, 1 by infinite is 0. So that is your what? 1 by n means what? If n tends to infinite, so 1 by infinite, the value will be 0. So that value, if this value is 0 and this value is 0, the value is 1 by 2, and that is your 16 into 1 by 2. That is your 16 by 2 and equal to, that is your 8. We have got the power, the average power of discrete time signal x of n equal to 8. Since the power is finite, here energy is infinite, and we have to check whether the power is finite or not. And here we got power is finite. Since the energy is infinite and power is finite, we conclude that the above discrete signal is a power signal. So conclusion what? Since energy is finite, since the energy is infinite, and power is finite, the above signal, the above discrete signal, the above discrete time signal x of n is a power signal. It is one of the most important question, has already been asked 2 or 3 times as in your BPUT, also some public service examinations. So this is your how to calculate or how to evaluate or how to identify whether the discrete signal is energy signal or power signal. So we conclude that if energy is finite and power becomes 0, we can say that the energy signal. If energy is infinite, then we will check whether the power is finite or not. If the power here in this example, energy is infinite and power is finite, if the energy is infinite and power is finite, the discrete signal is the power signal. So thank you students. Next class we will study, that is your periodic and aperiodic signals, even and odd signals, symmetric and antisymmetric signals, like this. Thank you.